By injecting this code, we exploit a vulnerability, extracting sensitive data, as shown here.
Okay, I want you to imagine something for a second. Imagine we're architects, but we're not building with steel or glass. We build with pure data. We construct these huge, shimmering vaults to protect our most valuable information. But here's the thing. Every vault has a lock, and every lock has a key. Today, we're going to explore a digital breach where the key itself gets twisted into a crowbar. Let's decode this. So in our digital world, these shimmering vaults, that's what we call a database. They are the invisible architecture holding up everything. I'm talking about your login credentials, the entire inventory of your favorite online store, you name it. And they're designed to be super secure, orderly, and of course, accessible only to the people with the right permissions. All right, so here's our roadmap for this explainer. First, we're going to look at the keys to the vault. Then, we'll witness the anatomy of a breach. After that, we'll learn how to architect a solid defense. And finally, we'll look at the ever-evolving blueprint for digital security. So how do we even talk to these digital fortresses? To ask them to store information or give us something back, we need a very specific language. We need the key. And that language is called SQL, or Structured Query Language. You can think of it as the universal key. When you use it correctly, it's this pure, clean command. It flows like liquid light right into the database, politely asking for exactly what it needs. The vault recognizes the request, opens up nice and smooth, and gives you exactly what you asked for. Nothing more, nothing less. That's the way it's supposed to work, right? A perfect harmony between the request and the response. But what happens when the language of the key itself gets corrupted? What if the words are weaponized against the very vault they were designed to open? And that leads us right to the anatomy of the breach. This is that moment when the key is no longer a key. No, it gets twisted into a digital crowbar, something designed to just pry the vault open by force. Now, check this out, because the contrast here is everything. On the left, you've got a normal query, flowing in that calm blue light. It's just asking the database to find a user with a specific name. Simple. But look at the right. An attacker injects a little piece of code right where the username should go. See that jagged violet energy? That's the SQL injection. That's it breaking the query's original logic. So here's the trick. And it's so simple, it's brilliant. It's this little piece of logic. 1 equals 1. Now, to a database, that statement is always true. There are no exceptions. By injecting it, the attacker completely changes the question. It's not asking, does this specific user exist anymore? Now it's asking, does this user exist, or is 1 equal to 1? And since 1 is always equal to 1, the vault's logic is tricked. It has to say, yes. And the doors don't just open, they dissolve into nothing. Let's make this feel real for a second. Imagine an attacker targets an e-commerce site's search bar, but instead of searching for, say, a t-shirt, they inject a destructive command, drop table products. That command travels like a lightning strike straight to the database. And this shows you just how dangerous this is. It's not just about peeking inside. In a matter of seconds, the entire product inventory, every item, every price, all of it, is just gone. Vanished into digital dust. You know, erasing data is one way to go. It's loud, it's destructive, you know it happened, but sometimes the goal is way more sinister. Sometimes they want to steal, not destroy. So using a totally different command, an attacker can trick the database into combining or unioning two completely separate sets of data. You can see it in the injected command there. All of a sudden, the search result for a product gets mixed together with a stream of sensitive user credentials, usernames and passwords. I mean, the stuff that should be in the deepest, most secure part of the vault is suddenly getting funneled right out through a tiny hole that was meant for a simple product search. And that right there is why this matters so much. It just takes one unsecured search bar, one forgotten login form, just a single compromised input field, and you can jeopardize the data, the privacy, and the safety of thousands, maybe even millions of people. Okay, that all sounds pretty bleak, but it's not hopeless, not at all. Now that we've seen how the breach works, we can focus on the solution. And this is all about architecting the defense, rebuilding our digital vault, not with thicker walls, but with a much more intelligent design. The number one defense is a technique called prepared statements. The best way to think of it is like a secure mold or a template for our queries. The structure of the command is already defined, and there's just one slot left open for user data. So when an attacker tries to inject their malicious code, it just doesn't fit the mold. It can't become part of the command. It's just treated as a piece of text. It's totally powerless. And that's the core principle that makes this all work. By separating the command from the data, which we call parameterizing queries, we are telling the database with no room for error, hey, this thing the user gave us, it's just data. Never, ever, ever treat it as a command you can run. That malicious code, that jagged violet energy we saw, it just bounces right off. Harmless. But a really strong defense has layers. So on top of parameterizing our queries, we use input validation. Think of it like a prism that filters everything, looking for malicious symbols and just reflecting them away before they even get near the vault. And we also follow something called the principle of least privilege. We partition the database into smaller, sealed-off rooms, kind of like a ship with watertight doors. That way, even if one area does get breached, the rest of the vault stays totally secure. All right, so this brings us to our final thought, the ever-evolving blueprint. Because in this super-connected digital world we've built, security isn't some static wall. It has to be a living, breathing, adapting system. And here it is. This might be the most important takeaway from this entire thing. SQL injection, it's not a new threat. It's been around for decades. The reason it is still so powerful, still so incredibly dangerous, is actually profoundly simple. As architects of this digital world, we sometimes just forget the basics. We build these complex, incredible structures, but we neglect the foundation. So, I'll leave you with this to think about. In a world that is built on these shimmering, transparent layers of data, where our lives and our secrets are all stored in these digital vaults, is the architect's greatest flaw, our biggest vulnerability, simply forgetting the fundamental rules of a secure design?